Hi, my name is Zhang Liyin. Today I will make a report on surface coordination layer passivates oxidation of copper. I will go through these three parts of my presentation. As we all know, copper is a commonly used metal in our daily life. It has good thermal, electrical conductivity, and ductility. However, there is no dense and stable passivation layer on its copper surface, and many widely used anti-oxidation technologies tend to reduce the certain physical properties. So, how to balance the strong oxidation, resistance, and physical properties? This article mentions three methods to achieve this goal. They are hydrothermal solver thermal treatment, room temperature electrochemical treatment, and introducing alkynyl ligands. First one is a hydrothermal treatment. The copper foil was put together with the sodium formate in water, and the mixture solution was sealed in autoclave, kept at 200 Celsius for 24 hours, and then collected copper formate. We can see the result intuitively in Figure 2. The copper formate showed a good luster after exposing in base solution. However, others without treatment did not show the good resistance. Raman band here came from the copper oxide species, which only appear in bare copper. Moreover, it showed good physical property. We can see from this figure there was little decrease of the electric conductivity of the copper formate. Although there was slight change in the peak potential, the corrosion current density of the copper formate was 20 times lower than that of the bare copper. However, changing the temperature to 160 Celsius for 24 hours, there were copper oxide species appear in the Raman spectrum, which means that the lower the temperature cannot achieve the passivation effect in the hydrothermal method. So how to get a passivation copper under 160 Celsius? Author found if change the hydrothermal to the solver thermal treatment, decreasing temperature can achieve the passivation. We can see from this figure. Besides, the passivation layer was effective at preventing the oxidation of copper under other harsh conditions, like hydrogen peroxide. However, the previous slide showed the solver thermal treatment without mantle precursor. After inducing the mantle precursor, the reaction temperature can be reduced to 120 Celsius. This method can also use in nanomaterials, like copper nanowires. From Figure 5, we can see the treated nanowires also showed good anti-corrosion properties. So why this treatment can induce the passivation? Surprisingly, regardless of which treatment system was used and which original crystalline orientation of the polycrystalline copper field was selected, the relative intensity of the copper 10 diffraction peak increased with the time. So indicate that deep lattice reconstruction of the copper surface took place during the formate treatment, and it can draw conclusion that the copper 110 formed with a thickness of the 200 nanometers, and the untreated copper remained copper 111. From this image, the steps on the copper formate were uniform with a height of 2.55 angstrom, corresponding to the diatomic step height of copper 110, indicating that the copper surface was mostly reconstructed to the copper 110 after the formate treatment. These steps appear in 150 Celsius and 300 Celsius, illustrating that it was formate play a major role in surface passivation, but not temperature. Next, to figure out what was the detailed structure of copper 110 surface, high-resolution images show the perfect copper 110 6+2 superlattice. Further, authors created a 6+2 superlattice of copper 110 with a 5-layer thickening slab to detect which coordination way copper and formate chose. Dinuclear unit, this one an oxygen ion, covered the surface, which was a novel modified structure. This structure can be regarded as copper valence decreased from surface +2 to subsurface +1 and then bulk atoms. After making sure the structure of passivation layer, it was obvious that while it can prevent oxidation, there were two main points. Firstly, the coppers on the top surface and subsurface were in oxidized state, and the active sites could no longer be oxidized. Secondly, the copper atoms on the subsurface were completely combined by oxygen ion and hydroxyl. These 2 points made oxygen atoms or other absorbers highly difficult to bind with coppers, leading to anti-corrosion feature. The second type of the method is a room temperature electrochemical treatment. Working electrode is a polished copper foil. A reduction potential was applied followed by oxidation potential. We can see from these pictures, the copper foil after treated by this method showed good anti-corrosion properties. The mechanism did not mention in this article. After searching some papers, it can be explained as at high potential these two absorbers would invade the copper subsurface and causing the copper to deviate from the initial position. When the potential decreased, the oxygen atoms on the subsurface escaped and copper did not have time to return to the original position, so the surface structure was reconstructed to the copper 220. The third method was putting the copper formate samples into the 1-DT ethanol solution. We can see after exposing copper formate with the DT and without DT to the sodium sulfide solution, not only the morphology but also the charge transfer resistance increased, indicating that the corrosion was indeed strongly inhibited by the DT modification. The mechanism of this method can be explained as 1-DT can coordinate with sites or the defects that were not protected by this unit, and it will form the sulfur-copper metal bonds and cross-link network, and which will prevent the absorption of the corrosive substance such as oxygen. These methods have been proved to extend to other applications. Based on the formate treatment, it can be used in the transparent conductive electrodes, which show the good conductivity and anti-corrosion feature. In addition, because electrochemical treatment can operate under room temperature, so this method can extend to roll-to-roll processing. What needs to be pointed out is that in the application of the formate technique, acid condensation with the pH less than 3 must be avoided. Finally, to draw a conclusion, there were 3 types of the methods mentioned in this article have successfully balanced these 2 factors. Coating with graphite organic compounds and silicon oil impregnated power oxides have been proved to resist oxidation. However, whether this method can resist oxidation without affecting physical properties needs to be explored more in the future. That's all. Thanks for listening.